So in the example 2 of the practice, you would like to follow the same steps. Step 1, right away, do we see any or any the H's protons attached to different atoms? Well, actually, let's draw this out. So if we were to draw this out, it would look like this. You would have a CH3, a CH2. Now, you have a C and two O's. The only way you can draw this is if you have, again, a carboxylic acid like that. Of course, this is the same idea here. We have a Br attached to a CH2, and then you have the double bonded carbon and oxygen. And then, of course, this one, just an alcohol. There is no double bonds or pi bonds. Very well. So number 1 is, does the element effect apply? That's the question. Does the element effect apply? Well, let's see. Our acidic proton would be this one, would be that one, would be that one. But they're all attached to the same atom, which is oxygen. So step 1, H bounded to O in each compound. So it's not helpful. It's the same one. We couldn't apply resonance, inductive effect, we couldn't apply electronegativity or size because, again, they are the same elements, the same atoms. So we would like to go to step 2. The question is, we start looking in the vicinity. Is there anything? Well, the only way we can do is by looking again, drawing the conjugate bases. So let's draw the conjugate bases. And drawing the conjugate base means you remove an H, and then there's a negative on O. Okay, pardon my drawing here. And then, of course, lastly is this one right here. Okay, so let's start. Is there resonance in each of these? Yes, there's resonance in the first one. There's resonance in the second one. So they both have resonance. Stabilized. Also, this one is resonance stabilized. Does this one have resonance? Nope, there's no resonance. 2. Anything else other than resonance? Doesn't seem like there's an halogen or an electronegative atom nearby, so there's no inductive effect. Now, does this one have any? Yes. So we have Pr right here, right? That's a halogen. So the electron density can be now pulled. So let me use a different color here. Yes, there's an inductive effect. This one, of course, doesn't have it. No inductive, we're just going to call it. Is there hybridization? Nope, they're all the same hybridized. So the question is, which one would win? Well, this one is only resonance stabilized. This one is resonance stabilized and has the inductive effect. So stabilized, of course, by the inductive effect. So therefore, this one has neither. So this would be obviously our least acidic. This would be our most acidic. And this would be in the middle, the moderate. So again, we're going to do more complicated topics, examples when we come in class. So be prepared, look at the homework, and of course, bring questions. The next one is, in the last video, is equally important to what we have been doing, and it's just to wrap up. It's Lewis acids and bases, and that's the end of that lecture, of this lecture.